Okay, here's a problem. You take the sine 105. You say, I can break that up into sine of 60 plus 45. There is a little app for that, so to speak, and it is this right here. You'll have to be given this. Well, you could have it memorized. It's not that hard, but if you are given it on the test, you should be able to go like this. Sine of 60 plus 45 would be sine of cosine of 45. Same sign as what they used, plus sine, nope, sorry, cosine, sine. Cosine 60, 45. I think my mic's cutting in and out. That's kind of freaking me out. Hold on. Okay. So now you do a bunch of little parts. I'm going to call on different people for different parts. Mr. U, would you tell me what sine of 60 is? And let me check. Yes, sine is opposite over hypotenuse. Root 3 over 2. You are correct. And then you pick on somebody else for the one. Okay. Cosine 45 is 1 over root 2. I agree. And then plus, pick on somebody else. Cosine of 60, adjacent over hypotenuse, 1 over 2. I agree. Times, pick one last person. All right. Sine is opposite over hypotenuse and of 60. Sorry, I was looking at the wrong thing. What's 45? Sorry, it is 45. So it is over root 2. There we go. Now, notice, nice feature. They have common denominators, and they will. So, at least on sines and cosines. So the final answer for this has a common denominator. The denominator is 2 root 2. And top is root 3 plus, no, that's 1 times 1. 1 times 1 is 1. Root 3 plus 1 over root 2. Raise your hand if you had that one right. Good. All right. That is a typical problem from yesterday. And yes, you'll have to know those kinds of things. Tests. And now for today. That is probably an R2 level question, because the problem is you just plug the numbers in. It's pretty simple. So the one for today is a little more complicated, but not much. The one for today, they're going to give you some new ones. And I will prove to you that you actually already know these new ones. They're called double angles. All right. Cosine of 2u is equal to cosine. Hang on, it's supposed to be a u. Theta. I'm theta. U minus sine squared u. All right. That is a fact. They give it to you in the test. Prove that it actually works. Would you agree? Sorry, that 2u is really the same thing as u plus u? I'm going to leave this side. I'm not going to touch this side. This side, I'm going to replace cosine of 2u with cosine of u plus u, because it's the same thing, right? And you just learned yesterday how to do that kind. You have cosine of something plus something, like u plus u, then that's the one we just did, right? Except cosine's a little different than sine. It's not sine, cosine, cosine, sine. Do you remember what the pattern is for cosine, cosine, sine, sine? Very good. Cosine, cosine, sine, sine. And do you remember what to do with the sign in between? Is it still the same as this, or is it the opposite of that? Opposite. So if they did plus, we have to do minus. So now watch what happens. U and u and u and u. Do you get that that's cosine squared u minus, what's that? Sine squared u. And isn't that the same thing they told us in the first? Okay, so we just proved using yesterday's techniques that this is actually a true statement. So when is it for handy? Let's say that you were in the middle of a problem, and this is given to you on the top of the paper. Say you're in the middle of a problem, and it says cosine of 2u all over cosine squared u minus sine squared u. supposed to be squared right there. You could be smart enough to know, oh, cosine 2u, I know that one. I can see that. Cosine squared u minus sine squared u. And once you make that substitution, now it's identical on the top and the bottom. And then everything cancels, and the answer is what? 1. Okay? So just like you knew before that wherever you saw a secant squared, you could replace that with the one with the coat. No, wait, the one with the tan. I guess in winter in Minnesota, it actually would make some sense to say the one with the coat is what we seek if we want to like steal it and keep warm. But no, that's not really what we're supposed to be doing here. In like Florida, it's the one with the tan. That's what we seek. Anyway, so my point is that if you saw a secant, you could replace it with this, right? So my point is, if you see a cosine of 2u, you can replace it with this. And that'll be given to you on the test. Okay? All right. Now let's go talk about like everything else you got to know for this test. I'm going to cover everything in a couple minutes here? No, but I can cover like the highlights, the really important stuff. One of the things that you're going to have to know is how to handle common denominators. And you're also going to have to know how to handle cancel. So I have a little section here called can or can't you cancel. Kind of catchy title, huh? Can or can't you cancel? So on this problem, can or can't you cancel the 5? I cannot. You'd be surprised how many people, when they see this, think, oh, I can cancel these signs. No, you can't. Can't do that. Why? Because there's a plus right here. What if it was 5 sine theta over sine theta? Then can you cancel? Can or can't you cancel? Yes, you can cancel in that situation. All right, here's another one. 1 over x plus x over 1. Can or can't you cancel? You cannot cancel over an addition like that. If this was 1 over x times x over 1, then could you cancel? Yes, you could. Okay. Next one. Secant squared theta over secant theta. Can or can't you cancel? You can. They both cancel and turn into what? A 1. How about now? Can or can't you cancel? You can. And it would turn into just what? Secant. Yep, just secant. Okay. Then, how about now? Can or can't you cancel? No. All right. Now this is an important one. This is more like can or can't you factor. Doesn't have a nicer ring to it. Can or can't you factor that? Oh, yes, you can. Now you might be thinking, wait a minute, there's not a secant involved. Don't think of it that way. Think of this as this. X squared minus 16 can be factored into x plus 4 and x minus 4. Remember? So that can be, go ahead, Mr. H. What was that again? Yep. So it can be factored. Okay, you went a little too fast there. Try again. Okay. All right. So that one can be factored. How about this one? Can or can't you factor? Yes, they both have a sign in them. So yes, you can factor. And what would you have left? 1 minus sine or sine minus 1? Because they are very different. 1 minus sine, yes. All right. You can factor that. And it would be handy if the problem had a denominator of, for instance, sine x, because now you could cancel something. Why can I cancel here? I thought I kept telling you that to add or subtract, you can't cancel. Because really, this is a big multiply problem on the top. That's why I can cancel those. Okay. All right. This one down. Secant squared minus 1 over secant plus 1. I'm having mic issues, sorry. Secant squared minus 1 1 over secant plus 1. Well, I can tell you this. You can cancel after you factor. So it's sort of like a combo deal. Can or can't you cancel, but first of all, it's can or can't you factor. And once you can factor it, then you can cancel it. All right, Mr. U, how did you factor the top? I'm using X, but that's fine. Plus 1. Okay, and then the one on the bottom is a secant X plus 1. And then that cancels that. And then the answer is secant X minus 1. Right? All right. Let's try one that's very similar but different. Oh, wait. Question? It's as simple as this. You don't want to go any further. It's done. Why I know? Because it's not squared. If there'd been a squared left in it, then there's a good chance there's some kind of a substitution I can do. The directions on this would just be to simplify. If the directions had been to find the angle, they'd have to tell you what it's equal to. Like they'd have to say equals 0. Yes? Can or can't you cancel? No. Why? Because it's an add or a subtract here. That's not a... you got lucky. That won't work every time. Okay? All right, it's sort of like saying, can't you just do this number times that number? You know, it works this time, but... All right. All right, can or can't you factor? Well, kind of. Can or can't you factor? Can't factor yet, but how could you? Good question. You cannot do this. I bet a lot of people think that. Why can't you divide by cosine on both sides, cosine of x? Because it's like dividing by a variable on both sides. Can I show you why that wouldn't work? X equals 2x, for instance. Okay, so let's divide this on both sides by x. Watch what happens. What's x divided by x? 1. These cancel, and what's the answer? Oh, 1 equals 2. All of math breaks down. So you can't divide by a variable on both sides. You can divide by numbers on both sides, but you can't divide by a variable on both sides. All right. The world will implode. So we can't do this, even though it would be nifty and it would make life a lot simpler, but it's just wrong. So I can subtract cosine from both sides. That's okay. I can subtract a variable from both sides. That's always been okay. Take cosine from both sides. And why is that good? Because now it's equal to 0. And anytime you do something like this, a couple things multiplied equals 0, you're on the right track. That's what we want. We want it to be two things multiplied, and that usually implies factoring. So there's a lot of factoring in this. And the factoring part gets it down into two parts that are being multiplied. That sets up the zero product property. And that says that either this has to be 0 or that has to be 0, and you just have two separate equations, you get two separate answers, etc. Okay, so how do we get to there? So let's get back. Oh, ooh, undid a little too far. Let's redo a little bit. Here we go. So if I'm going to finish from here, I just need to get cosine squared x sine x minus cosine x. And now I ask you again, can or can't you factor? You can. And when you factor, you'd get what out of both parts? This and this has a cosine. And then what's left is a cosine sine minus 1. Now, this has two parts. Either this part's 0 or that part's 0. All right, this would be a pretty ugly one, actually, because this part's easy. cosine x has to equal 0, and you say, oh, where's cosine equal 0 over 1, and that must be not be a normal triangle, so I got to go cosine is x over r, and where is x equal to 0? 2 spots. Right there is a spot where x is 0. Right there is a spot with 0. I the answers for that one. Okay, but this other part, you wouldn't have one like that on a test because we haven't done stuff like that. You don't have to graph that. Good. So back to the other one. Did you get how I got this one or not?
Yeah.
I said the answers were 0 and pi. I didn't say that? You think it's wrong? Okay, let me double check that. Okay. So where is cosine equal to 0? Cosine is the... Here, let me write this. Cosine of x equals 0. I'm going to put this over 1. Would you agree that this is x over r? And where is x? Here and here. Oh, you're right. I was doing where is y 0. I wasn't doing where is x 0. Okay, sorry. I went too fast on that one. Thank you for catching that, because somebody might have been confused at home into drugs, and then that'd be awful. All right. So this is actually 0 right there at 0, comma 1, and at 0, comma negative 1. And so it's at pi over 2 and 3 pi over 2. Thank you for clarifying that. Okay. I was trying to just get through that quick so I could get to this, but I at least need to do it right. Okay. All right. So then let's not spend too much time trying to figure that one out, because that one is not going to be something you'd be expected to know. Okay. So let's refocus then. What was I trying to teach you on this one? I was just trying to show you that if you same side like this, then you can factor stuff out. And I had a cosine in both of them, so I can factor it. All right. I think the next part is, before lunch, maybe I can get this last part done, which is it's proving. On the top of the worksheet, they ask you to prove this new stuff works. So we're going to use the old stuff to prove that the new stuff works. Yes. If the answer is limited to between 0 and 2 pi, it usually does not include 2 pi. So the question was, if you're picking between saying 0 or 2 pi, just say 0, because 0 is almost always allowed in the interval, and 2 pi is pretty much never allowed. So, all right. And one more thing on the test, the common denominators. We didn't really spend much time on that. I'm changing my mind. I'm going to start this worksheet after lunch. The last thing I want to talk to you about is common denominators. If you need space to write, back side of the worksheet I just gave you has a big empty spot at the bottom. Come on, hurry up. All right. This one, we said it couldn't cancel, but can you actually add them? Yes, if you get a common denominator. Okay, so how would you do that? X would be a good common denominator. So this one's already good. He's good to go. How about that one over there? Nope, needs to be fixed. Multiply by x here. Can do that. Can also do it on top. Then it's okay, because really I just multiplied by 1. That's why that's okay. So this was 1 over x, and this one's x squared over. And then can they actually be added together? Yes. 1 plus x squared over x. And then, now that we found a common denominator and got this answer, that is the answer. And more likely on the test, it won't be that simple, of course. It'll be having tangent in there. And then you'll be smart enough to know, oh, the one with the tan. What's that? Secant. So it'd be secant on top. And then maybe there'd be a secant on the bottom or something too, and it would cancel. But the point is, you'd have to know how to find a common denominator. So you figure what you want for the denominator, and you multiply it here and here. All right, we'll do more of that after lunch. Back from lunch, and that is not it. That's the review for higher algebra. Okay, we were talking about finding a common denominator when you left, and that's an important skill to have. Let's do one more like that. Let's say that you had tangent. Right away, I hope you're thinking, oh, the reason he's using tangent is because that has a denominator. What is the denominator with tangent? Cosine, because it's really sine over cosine, right? And then I'm going to add that to just tangent of theta. So now, I'd like you to make these into fractions, make them have a common denominator, Yeah, yes, you could have factored this, yes, but I'm asking you to try to add them together into one big theta. Sorry, that's theta. All right, here's what I was going for. Sine squared theta over cosine squared theta plus tangent of theta. You understand, see me? Okay, you got a point there, and it's getting closer. So tangent could be sine over cosine. Does it have a common denominator yet, though? No. So if it has a common denominator, we could multiply cosine over cosine, and then now it'll have a common denominator. And now it's going to be sine squared plus sine cosine all over cosine squared. And why on earth would you ever have wanted to do that? Hold on, I'll tell you why. Yes, because I said so. It's not that. All over cosine squared. Why would you ever want to have done that? Because what if the original problem had been... my smartboard's freaking out here, hold on. What if the original problem had a little factor over there that you were multiplying this whole thing by cosine squared? Then all of a sudden now the cosines could cancel. And then you'd have a final answer of that. Except that could be factored, although I'm not sure it would really help anything, but yes, you could take a sine out of both of them. All right, main thing is, I'm just trying to reinforce, you need to know how to do common denominators. You need to know how to factor. You need to know how to cancel. And let's bring it back to the stuff we started the hour with. If they said sine of 2 theta, you should not think, oh, I'll just divide both sides by 2. You can't fix them that way. You have to have the little formulas that they give you. If you look at the worksheet I gave you, you should have it in your hand right now. You should be able to tell me what sine of 2 theta is equal to. It says right on your sheet. 2 sine theta cosine theta. Is that what he's reading that right? Okay. Is there something else that's a sine of 2 theta is equal to? Okay. Well, then that's your only option. All right. What about cosine of 2 theta? Do you see that there are several things that cosine of 2 theta can be? And if you see a problem that says cosine of 2 theta in it, and it's cosine of 2 theta over, I don't know, let's say, for instance, 1 minus 2 sine of theta. Just sine of that. I'm sure I wrote that right. No, it needs a, does it need a sign? It needs a square, yeah. Okay, so let's say the problem was like this. You'd have to be smart enough to know, oh, I can replace that with, and you look on the sheets and you find something logical, and oh, I see the exact same thing. 1 minus 2 sine squared theta, and I've now got the same thing on top as the bottom, and then they cancel it. So you now know a few more, and these are kind of nice ones in that they'll help, but you're going to have them on the sheet. You'll know, okay, I see it's a 4 theta, or it's a 3 theta. I have to go find it on the sheet. Actually, 2 theta is more likely because it's actually on the sheet. All right. So let's actually do the first problem together. I handed it out a while ago. Some of you may have already done number 1. Have you? All right, good. So let's do number 2. All right. Number 2 says cosine 2u is equal to 2 cosine squared u minus 1. All right. Remember, in a proof, you're supposed to be leaving that side alone. The point is we're going to figure out that it equals this at the end. Oh, it does equal 2 cosine u squared minus 1. So we leave that side alone. We just have to take this side and keep manipulating it until it turns into that. So cosine of 2u, my first thought, I bet you is the same as yours. What change this into cosine of what? U plus u. All right, let's do that. We can do it that way. Okay, now u plus u, it says use the appropriate sum or difference identity. I can't go grab one of the other ones at the top of the page and plug it in here. I have to use a sum or a difference. So I could have used the difference and said 4u minus 2u. That would have been okay, but it's probably easiest to just use the plus. All right, so remember this thing for cosines? You have to look at the last worksheet or have it memorized. Cosine was, remember what it is? Cosine, cosine, sine, sine. And it's the opposite sign. So if this is a plus, we do a minus. Okay. And then it's u and u and u and u. And then that's really cosine squared u minus sine squared u. And then this is where the moment of eureka has to come in, because that's not equaling the other side. This is not the same as this. So what do I do? Nope, false. That rage quit is not an option. It is in a video game, but not here. Okay. How about this? Isn't this whole unit been about substituting things? Yoink out one thing, put in something else? Think about it. Think about it. Ooh, sine squared could be replaced with... Yes, it's true that sine squared plus cosine squared equals 1, but this is just a sine squared, so... Replace the sine squared with 1 minus cosine squared. Now there's a frightening number of answers that weren't right there, so I'm going to go off to the side and say it was based on this. Sine squared theta plus cosine squared theta is equal to 1. And all I had was sine squared, so I had to get this alone, so I moved that over to the other side. It was 1 minus cosine squared. Now why is that helpful? Because now when you distribute this negative out to here, you'll see we have a negative 1 in our answer, which we needed. And when you distribute this negative over to that one, you'll have a positive cosine squared, which goes with the other cosine squared in C. All right, so we've proven it. All right, do the same kind of a deal for number 3. You're going to break it up into a u plus a u. Then you'll have to do some kind of a genius swap out of something, and it'll all work out. That's how you do number 3. Start with cosine u plus u, and leave the right side alone. All right, let's move on to problem 4 on the worksheet. We'll do that one together with you. Quattro. Sine 2x equals 2 sine x. And I had a kid that asked me last hour, can't you just divide by sine x on both sides? And I didn't have a real good answer for why you could not. I knew that it wouldn't work, but I couldn't say why. I showed you earlier about how if you divide by x, it can cause the world to explode or implode. Either way is bad. So you can't divide both sides by sine of x, not an option. So, give me something else I could do. What do you always want to set these puppies equal to? 0, and then you always want to what them? Factor them. All right, so set them equal to 0 by getting this over to the other side. Granted, I could do it the other way, but I'd rather do it this way. So sine of 2x minus 2 sine of x is equal to 0. Now it's set equal to 0. Is it a multiply? No. As soon as this is a something times a something equaling 0, my life will be good and I'll be almost done. I just have to set these equal to 0 on each side. So what factors out? I can't factor anything out yet. Why can't you take out a sine? Because this is a sine of 2x. That's a little weird. Where have you ever seen that before? Maybe at the top of the page? So sine of 2x could be replaced with... Let's see, I know it's a theta on the top of the page, but you can make the transition there and say this would be, what? 2 sine x cosine x. And now I've got a sine in both of them that in fact, I got a 2 sine in both of them that I can take out. And then I'll have something factored. And once it's factored, I can set each side equal to 0. So I have the 2 sine x comes out front, and then I have cosine x minus 1, and then both sides, both parts can be set equal to 0, and then you'll have multiple answers. And then if it said at the top of the page, find all the solutions, you'd add plus 2 pi r. This says all between 0 and 2 pi, and I say r often because 2 pi r squared plus 2 pi r h got kind of drilled into my head as one of those main formulas I taught for 16 years in the middle school. So whenever I say 2 pi, it naturally just says r because that's in this other big formula. 2 pi n is fine. If in fact you want to use 2 pi r, go ahead. It's just a variable. It could be any letter you want. Yes, sir. Good question. I like to put plus and minus because unless they've asked for all the solutions that are positive would only go one direction. Now you could cover that by just saying plus 2 pi r. Like, so again, answer comes down to say pi over 2 on one of these. And then I say all the solutions, I'd say plus 2 pi n. Again, I'm open to you saying 2 pi r, 2 pi n, 2 pi q, whatever you want, whatever letter. But the question really that I was just asked was, do you have to have a minus there? Not really, because do you get that this n right here could be negative? And that would cause this to go in the negative direction. So you can be plus, or you can be plus or minus. I don't care. It's fine. Just suppose it could be minus, because then you could have a negative in there. We'd cancel it out and make it positive. So the easiest thing, I suppose, is to write this. And if you want to throw in a plus or minus, you're getting the idea that it could go negative or positive direction, and I like that too. So either way is fine. Okay. Any other things you want to ask about? Okay, then, you got a bunch of time to work. And I did tell you, did I not tell you a couple to skip yet? Or, all right, I did or didn't? I did not? Okay. So everybody please look at the back side, and I'm going to tell you some to skip. 11 and 12. This worksheet feels a little bit long, so it's okay with me if you skip 11 and 12. Okay, get to work. If you need help, ask. Tomorrow's our last day of review for the big test.